Good day, everyone. My name is Nazgul Siralina. I am from Kazakhstan, Almaty city. In slide, you can see our beautiful mountains, nature, and our university, Kazakh British Technical University, which is open to student exchanges and collaborations. More information you can find in our website kbtu.edu.kz. Today I am going to present my PhD project on title Anomaly Detection Framework. My supervisor is Asel Akjalova. She is PhD in computer science. So today financial organizations' main problems are increasing number of clients year by year, improvement of financial products and the services, and the anomaly detection incorporate information systems which influence to the productivity, reliability, and availability. So our purpose of our work is to develop a framework of network and the system behavior for keys and suggest an approach for detecting anomalies in the test case of issuing virtual cards. In order to achieve the purpose, we divide it into tasks. Firstly, to observe anomaly detection literature review. Secondly, to find effective solutions which are used in productions. Thirdly, to suggest an architecture model in the process of issuing virtual cards. Fourthly, it is to propose the process of distribution and the sequence diagram of issuing virtual cards. And finally, to build web services that can effectively solve the problems of big data queries in the test case of issuing virtual cards. In next slide, you can see the architecture of anomaly detection. The input data is entered to the input data component. Then it is sent to converter to VSDL, which data is transferred to VSDL format. Then the data is sent to ESB, enterprise service bus, and the data is sent to anomaly detection agent where the fixes anomalies. The status detector analyzes and fixes the anomalies and prepare input parameters for machine learning model. They are observation interval, packages that are transferred from the sender to receiver, simulated channel characters, and the entrances to data sets. As the work of machine learning component, the output results are the amount of data transferred from the user. If it exceeds, then anomaly. The number of transmitted data packets. If it exceeds, then it is anomaly. The number of connections. If it exceeds, then anomaly. Connection duration. If it exceeds or decreases, then it is anomaly. Or if it is falls off by timeout, then it is anomaly. Then anomaly classification categorizes the anomalies. If they find new anomalies, so it sends to new anomaly component where new anomaly is added to database, and with the help of logging files, that generates recommendations for user. If there is no new anomaly, so there work agent which works with that anomalies and fixes and get the needful useful results. So in next slide you can see the test case of issuing virtual cards. It is sequence diagrams, and in that business process there are used the next terms: virtual card, which is the card issued without a physical medium; PC, it is physical processing center; ESB, enterprise service bus; ABIS, automated bank information systems, and the PC DSS. This payment card industry data security standard. In mobile application, client requests the getting card, then it sends to ESB, ESB sends to the ABIS, and the PC firstly generates the pack of cards and sends to ABIS the information about virtual cards, and the ABIS sends the virtual card to ESB, and this virtual card data is sent to mobile application where a client can see the information of his or her virtual card. So we use the next software tools. It is PL/SQL programming language, PL/SQL developer, Oracle database, mobile applications, iOS, Android, enterprise system bus, and the processing center. So in next slide you can see web services which we built. So we built web services ESB request card and the ESB answer part. Input parameters, this is output parameters. So you can see the example of income parameters. It is request ID, request date, client ID, client identification number, client name, surname, and the mobile phone. And in that table you can see the example of outcome parameters. It is request ID, request date, client ID, card number, expire date, embossing name, card ID in ABIS, card start date, end date, and the card ID in PC. So we execute the following steps. We look different types of outliers in keys. They are application unobtainable, ESB inaccessible, ABIS unavailable, PC non-existent, and so on. So we analyze these errors in log files and solve these anomalies in ABIS. So we edit the meanings of attribute, mobile phone, expire date, name, surname, patronymic, and the date of birth to one particular format. We encrypt the card data according to this PCI DSS format. So we observe that our approach decreases the number of outliers. So in next slide, we define count of clients, which are 1000, and we define in our logging files the count of errors. It is 125. We define reliability, the execution of all services in the business process of issuing a virtual card. We determine productivity as the interaction time in the execution of all web services. We define storability, storing data information, calling the services and the operations. And as availability, we determine getting an opportunity to call services in particular keys. Accuracy, we define as the correctness of entered data by the client. So reliability is 8,859 points. Productivity is 41,116 points, and servability 820, accuracy 795, availability is 781. So as next slide you can see our results. We prepare a discussion on anomaly detection, we apply architecture model, we illustrate the process of distributing virtual cards, we interpret the sequence diagrams, transmitting data of virtual cards in keys, we solve the problems of big data queries and improve characteristics, availability, accuracy, productivity, reliability, and stability. We use log files which help to identify anomalies in keys. We present the income and the outcome parameters of web services. We configure the timing task. We improve the overall performance and the scalability of keys. So our future work is to develop the architecture of self-adaptive systems for machine intelligence to automated software testings. Thank you very much for your attention.